we have Jamie Hannaford talking about, believe it or not, generating document APIs. He works with Rackspace as a software developer. Go ahead.
Hey? Yes, good, okay. So how is everybody? Was lunch okay? I think the mic's a little bit too close. Nice. There we go. Okay, so hi, my name is Jamie, and today I want to talk about how we can generate documentation from APIs. So I have 4 questions I want to explore today. The first is, what are some of the conventional problems that we face developing and documenting APIs? Now, development and documentation have an especially close relationship, so I want to focus on how they can work better in tandem rather than being estranged from one another. The second question I want to explore is, how can we centralize the information that we produce? Is the concept of don't repeat yourself a feasible one when we document? Now, our jobs require us to parse, handle, and produce quite a lot of often discordant information. And regardless of how techie we think we are, nobody likes to repeat themselves and nobody likes to duplicate effort. So is there any way that we can mitigate this problem? The third question is, how can we improve communication and team dynamics? Now, communication is one of the most challenging aspects of any team, but especially so with distributed, remote, and diverse teams, because not everybody has the same technical experience or knowledge. So effective communication is of vital importance. And the final question is, how can we streamline production and save our time? Because time is important to all of us. We want to focus our energies and we don't want to be drained by doing all of the things. So I've made some assumptions on my talk today. I've assumed that everybody has a very, very basic knowledge of what HTTP is, and potentially even REST. And if you don't know what REST is, it's simply a way of using HTTP to do certain tasks. So for example, if I want to create a user programmatically, I would use a post HTTP method. So I'm using the inherent structure of HTTP. The second assumption is that we all have a very, very vague familiarity with JSON. And if you don't have much experience with JSON, it's fine. It's simply a way of being able to serialize data into a consistent format. So I think the first question we really need to ask when we are exploring the problems of documenting APIs is, what actually is a web API? Now, the common definition is effectively an interface that allows users to do something, to perform a task programmatically. They can perform particular actions, they can interact with persistent state. So, for example, I may want to retrieve a full list of my Twitter followers. I could want to add somebody on Facebook using an API. And in 10 years' time, I could do something like view the status of my fridge if it's connected to the internet. So it's a way to enable and empower people to do things. Now, another definition is that an API is a contract. 2 of its hallmarks, the first is that it is a consistent thing. It's a specification of remote procedures. It doesn't matter whether I execute it now or in 5 years' time. As long as I meet the obligations of that contract, everything should work. The second hallmark of an API is that it is, in essence, instructive. It dictates exactly how 2 software components should interact. And the third and probably the most interesting characteristic of an API is essentially it's abstract. It doesn't matter how it's implemented on the back end. All that really matters is that its obligations, which are dictated by the contract, are met. And it doesn't matter whether you implement it in Python, in Java or PHP. An API is abstract, it's generic. And our job as doc writers is to communicate this API contract in a simple, effective way. And I don't think there's a better way of learning about how to document APIs than to actually create one ourselves. And that's exactly what we're going to do this afternoon. So let's create one. So our API is going to be an adopt a cat API. So just imagine we have a cat shelter. That's our business. And because we're techie, we want to programmatically interact with our cats. So what is a cat? Well, okay, in our system it's going to have a unique ID, it's going to have a name, it's going to have a fur colour, it's going to have an adoption status, and what the hell, let's give it a selection of favourite toys. And if we think about the operations that we want to expose to our users, well, okay, let's say that we want to allow somebody to list all potential cats. We want to allow somebody to check the status or the details of their favourite cat, of individual cats. And we also want to allow people to create new cats. So how would we implement this? So to take one example, let's implement it in Python. We can use a web framework called Flask, and we can sort of begin to implement our 3 operations. So I've kind of truncated this Python file, and I've omitted all of the implementation logic because, as we already know, an API is an abstract thing, so it really shouldn't matter how we implement it in Python, so I've just used ... But the 3 most important things here is that we see the structure of our API. So if we want to list all potential cats, let's give it a route. Let's say that in order for somebody to get the list of cats, they need to execute a GET request to /cats. Simple. What about if they want to retrieve the status of their favorite cat? Okay, so it's going to be /cats / its unique ID. Again, fairly simple. What happens if somebody wants to add a new cat? Now the difference here is that we're using a POST request as opposed to a GET request, which the above 2 actually use. And again, the route for adding a cat is going to be /cats. So we have our 3 operations here. Now let's see whether it works. So I actually implemented this in Python, and I created a server, and this now is listening on localhost against port 5000. Now, this isn't fully interactive, this is a screencast. I wasn't brave enough to do a real demo. I don't think I sacrificed enough to the demo gods. But I hope everyone is settled on a screencast. So, we have our server active. It's listening on localhost, port 5000. So we can use a tool called curl to simulate requests. So let's try it out. So we want to get a list of cats first. And because we have no cats in existence, it should be an empty list, which it is. So let's add a cat. We know it's a POST request, so let's specify the POST method. We know that we want users to send us a blob of JSON, so let's specify the content type header. And we also know that they have to send us a structure in itself. Now we haven't actually explicitly defined how this structure works, but let's just say it's a JSON object. It has a name field, a color field, and a toys field. And the toys is an array of strings. Okay, we've added one. There's a success message there. So let's see whether it's reflected in our list. And it is. It's successful. Now let's retrieve the specific details of our favorite cat according to its ID. We can't probably say we can. Okay, so we know our 3 operations work. We have listed all the cats, we have retrieved details of a specific cat, and we can add a cat. Okay, so for all intents and purposes, our API works. But when we want to document this API, what do we do? What position are we left in? Now, in this particular instance, we can see that the central logic of our API, essentially how a cat can potentially be represented, or how a toy can be represented, is encoded in the Python file itself. And we can also see that it's very tightly coupled with database logic, because, for example, we are defining name to be a database column of strings of maximum 80 characters. So how do we translate this information into our documentation? Now, the conventional approach is to duplicate this data into a more human-readable textual format. So, for example, we could have an introduction where we talk about what is a cat, how it's represented in our API. We could talk about all of its properties. We could talk about the type of those properties. We could then go on to enumerate all of the different HTTP requests that allow people to do things. We could describe all of the potential error codes, all of the statuses. But the fact is that as content permeates across our doc portal, duplication is not the only problem. Because as the information grows, so does the burden of maintaining it, which also introduces the risk of inaccuracy. And if there's anything that developers dislike in documentation, it is inaccuracy. And this problem of inaccuracy and duplication is only going to get worse as the API footprint grows and as more features are added. But I think there's an even more fundamental problem at work here in terms of this process of translating code information to human-friendly documentation. And I think the problem is that in order for this process to work, it's predicated on the process of seamless communication and transparency between the developer who implements it and the writer who documents it. And as we all know, communication is hard. It's often not the case to get a full transparency between different members of the team, because for many teams there is always a knowledge gap between developers and doc writers. So the natural question is, can we bridge this gap somehow? Can we bridge this knowledge gap? Can we avoid the accuracy drift? Can we centralize information in one place so that it's commonly understandable to everybody, and sort of get all the stakeholders of a project on the same level? And the simple answer is yes. One such project to enable you to do this is JSON Schemas. So if you're not familiar with what JSON schemas are, they are simply a way that allow us to model our API data like a cat resource in JSON. So we could describe what properties it has, what are their types, and we can also add summaries and descriptions for each of these properties to fully communicate this structure to our users. And we can do this using keywords. So JSON schema is a standardized it's a standard set up and codified with IETF. So there is a particular allowance of keywords that we could use to model our data in a consistent format that everybody understands. And what it also allows us to do is it allows us to translate our assumptions of how something works, of how something is structured, into a common format for everybody to understand. So knowledge is, it's not Kabbalistic or secret anymore. It's widely available and widely understandable. So I think the best way to learn about how JSON schema works is to actually write a schema. So let's write one for our cat. So this is the output that we got from an operation earlier that retrieved the details of our favorite cat. And we can kind of make sense about it. We know, obviously it has a color, it has a unique ID, it has a name, it has a status, etc. But actually there is sort of a creeping sense of ambiguity here. We don't really have full confidence in what the range of options can be for this arbitrary JSON blob. How do we actually contextualize it and add meaning so that everybody understands what the range of possibilities are? So if we create our first schema, again it's in JSON, we can assign it a top-level description where we say, this arbitrary JSON blob represents an adorable cat. It will always be a JSON object, and we can then go on to describe all of the separate properties that compose this top-level JSON object. So the first one, the color. What type is this value? Well, it's a string. It's not an integer, it's not a boolean, it's not an object, it's not an array, it will always be a string. So we can use the type keyword to describe that. And when we think about the color, the potential colors of the cat, well, it's not really going to have a rainbow color unless we're dealing with neon cats, which I don't think we are. It will only ever have a reduced scope of colors. So let's enumerate them, and we can do that using the enum keyword. And we can say that the only acceptable values that will ever be accepted for this particular keyword, for this particular property, is 4 values. And consequently, these are the only values that you will ever get back from the API. So we have immediately reduced the scope to these 4 individual values. Now what about the name? Well, again, it's a string. It's not an integer, it's not an object. And we can add additional validation logic here. So we can sort of say, all of our cats will always have a minimum length of 3 characters. They will always have a maximum length of 15 characters. We have very succinctly, again, reduced the possibility of options here. And we've done it in a very simple to understand way. And it avoids us to have to write an entire paragraph or 3 sentences to describe this problem. We have very succinctly described the range of options here using the keywords set out by JSON schema. We can also describe the status. It's a Boolean, it will never ever be anything else. And it also has a default value, so users do not need to provide this when they add a cat. It will be assigned this default value of false. And lastly, I think the most interesting substructure here is toys. So we know it's an array, but what is it an array of? Well, if we look at the elements here, they are strings themselves. And we can use this items keyword to nest a schema inside the array. So not only do we know the top level of the array, but we know what all of its child elements will be to and how they will be composed. And again, we can add additional validation logic here. And we can sort of say, a cat will only ever have a maximum of 3 toys. They're not greedy, they're not going to have 5 or 10. They will only ever have a maximum of 3. And they will also have unique toys. So it's impossible for a cat to have 3 balls or 3 spools of thread. They have to have unique items. And so we are contextualizing this data here and making it fundamentally understandable to everybody who uses our API. And if we add all of these properties together, this would be the eventual file that we would end up with. So, all of this is pretty cool, it's pretty interesting, but let's back up for a moment and try and summarize in terms of, and get a perspective about what it offers us as developers and doc writers. So to go back to this problem of duplication. Now with JSON schemas, we have defined this structure in one place. We have centralized representation, and all of our subsequent code and documentation references this canonical location. So we don't have duplication anymore, and again, we don't have the threat of inaccuracy. Also, JSON is one of the most prevalent data formats in use today. It makes sense to people and applications regardless of tool or language because it is widely supported in many standard libraries. So by adopting JSON schemas, we know that our presentation to our users is going to be in line with what they assume. We're not rolling out our own proprietary data format. Also, because this is a codified standard set up by the IETF, and it has incredible support in the open source community. So there are so many libraries out there that can actually do the validation on our behalf. We don't need to write any of that. Because it's supported by the community, somebody has already gone out and made a validation library for us. So we are saving time. And we're also making our validation more sort of comprehensive. And the final really cool thing is that because JSON schemas themselves are just JSON documents, we can publish all of these validation rules. So not only do we get the benefit of validation where we sort of say a cat will only ever have a maximum name of 15 characters, we can actually expose those rules to the people who use our APIs. And it requires no additional writing on our behalf. We don't need to write a page of validation rules. We have already codified them in our single schema. But unfortunately, it's not enough. JSON schemas helps us formalize our structures. It helps us model our data. But an API, when we think about it, is more than just resources. It's more than just models. What about HTTP verbs? Which HTTP verb do I use for creating a cat? You will notice that JSON schema doesn't tell me anything about that. It doesn't tell me what URI paths to hit. It doesn't tell me the different permutations of models. It doesn't tell me the response codes or the potential errors for doing something. JSON schema allows us to structure our data, but it doesn't allow us to structure our API. So to do that, we can use another tool that is more comprehensive in its scope. And 3 of the most popular are Swagger, RAML, and API Blueprint. For the sake of this talk, I'm just going to focus on Swagger because it's the project that I have most exposure to, and it also supports JSON schemas outside of the box. So if we look at how a Swagger file is defined, we can immediately get a top-level perspective of how our API is structured according to its path. So if we have the /cats path, we know very easily that it has two associated operations that act on that path. And the same goes for the other two paths listed below. And if you see a substring wrapped in curly braces, that simply indicates that it will be replaced by the user. So they will actually pass in that ID rather than the literal translation you have there. And we can assign descriptions to each top-level operation. And sort of, I think it's a very, very easy to understand way to see how everything is structured and fits together. We can also drill down and define how each operation is structured too. So if we take the add a cat operation, for example, we can add a description to it, and we can also enumerate all of its parameters. Now, we saw earlier that the create a cat operation has one single parameter. It expects a blob of JSON, right? And we made sense of that JSON in our schema earlier. So we can actually describe the parameter here. We can assign it a name and a description. We can indicate its location in the HTTP request. In this case, it will be the body. And we can also indicate that it is a required parameter. And if a user fails to provide it, the whole thing will fail. And we've done that using very succinct keywords here. And the coolest part about this is if we look at the bottom, we can actually reference our external JSON schema inside our Swagger file. So we don't have to duplicate anything again. We have defined it once in our JSON cat file here, cat.json, and we're actually referencing it in our external Swagger files. So I think that's a great way of defining once and reusing everywhere in a consistent format. Swagger also affords us a bunch of other cool functionality too. So apart from giving us a very cool, neat way to structure our data, we can actually generate documentation from our schema files. Now this is just, the contrast is very bad, I apologize, but these slides will be available at the end, and I promise it's beautiful, the docs. Take my word for it. So we can see here that it has a 3-column layout. We can see 2 of the columns. The left is for navigation, and the central column is where all of the bulk of your content would live. So, and on the right column, we can see the JSON samples for each consequent operation, and we would also get all of the parameters listed on the right too, and I'll show you that slide next. Now, what's really cool here is that we have defined our schema for Swagger in one file, and we can generate dynamic documentation that we know and we have confidence in can be 100% accurate. And all of this is very configurable too, so if you don't like the style, if you don't like the CSS, if you want to add some HTML, you can do that. All of this tooling to generate documentation is 100% open source, and you can actually modify and hack things to suit your business needs. So we can also see how parameters are documented here. It's not that clear. Do we have a laser on this then? I do, cool. So this is the JSON which we'd get back here, again, in shocking contrast. And we can also enumerate all of our parameters here, each with consequent descriptions. And you can't really see it from your point of view, but you can see the types of each parameter too. And this is documented in one single command line operation. And I think it's really cool to be able to generate semantically meaningful docs from a centralized point of authority. I think it's really powerful. But Swagger actually allows us to do more too. So we can actually generate a sandbox environment for our users. So apart from having a static interaction of content that we present to people, we can actually allow them to kick the tires and to experiment with our API. So they can, for example, paste in example JSON, send it to our sort of test API, and get an actual response back from what would be a production environment. So we're empowering people to experiment with that API, and I think we're exposing data in a lot, nicer interactivity level than just giving it out to them in a one-way conversation. I actually have a screencast of this too, but I don't think you can see it. So we can paste in some example JSON here, and we can actually send it to the API and get back an exact response that we would get if this was in a production capacity. So I think that's really cool. I mean, it allows users to, use your API. It gets them up and running very quickly, and it also lowers the barriers too. Now, we can do even cooler things too. So one of the things about APIs these days is that having an API is often not enough. You need to have SDKs, which are libraries and languages that allow developers to easily consume your API. So people don't want to have to worry about transport logic like curl and HTTP headers. They want all of that handled for them, and they just want to consume a method in a library. And we can actually generate SDKs from our one Swagger file in a simple command line tool. So I have a screencast too. So we can see this would be the inside of our directory. We can run the generate tool in a Docker container. We reference our local Swagger file. We specify PHP as the language we want to construct, and we specify an output directory. And we can see all of these files, all of this code that's been automatically generated based off our one Swagger file. So if I have a PHP community who I want to service with my API, I can generate this library for them, I can output it, I can send it to them, and they can just reference it in their code without having to grok much about my API. It's a very simple and idiomatic approach for language developers. And there's wide support for Ruby, Java, Python, a whole bunch of different languages. And actually you can do even more with Swagger too. So we mentioned earlier that the Flask app which we had, we sort of defined each operation itself. We actually didn't need to do that. Swagger can actually generate a server for us too. So if I'm a doc writer and I know the structure of my API, I can write a Swagger file and I can generate the server that will handle those requests. So I've kind of cut out the need for developers, to be honest. If I can document something and I am confident in the data that that I want to expose to my users, I can generate a server that will handle the API requests, and I can generate libraries for my developer community to use. And I've done that using the open source tooling that Swagger affords. And I think it's incredibly powerful. So to wrap up, what are some of the problems that we explored today? The central problem I think we all face is duplication. Nobody wants to repeat themselves or duplicate the information that they produce. And I hope I've sort of introduced to you some open source projects that can help mitigate and reduce this risk, because it allows us to define once and reuse everywhere in a consistent format. And I think we should be excited about this because it puts documentation at the heart of an API. I think it also puts documentation at the heart of a business too, because it democratizes the process of producing, documenting, and consuming business logic. Because now it's all done in a consistent format that everybody understands. We are leveling the playing field here. We no longer have knowledge silos that require intense bouts of communication between different teams. We have a common format that everybody understands. Dostoevsky once said that much unhappiness has come into the world because of bewilderment and things left unsaid. I think this quote is incredibly pertinent to what we do as doc writers and developers. Our job is to leave the world a less bewildering place than it was when we entered it. We all have that ability to do so with our code and writing. So let's go out and do exactly that. Thank you.
Thank you, Jamie. Developer, and doc writer, and quotes Dostoevsky. So, pretty awesome. He'll be there or nowhere answering questions. We have 10 minutes and then the next talk.